Hello my dear students, welcome back to Learn Physics. In today's topic we are continuing with our current electricity chapter. Okay, so this one, yesterday I gave you one check your concept question, right? So in the question was the galvanometer in each of the two given circuits does not show any direction. Find the ratio of resistors R1 and R2 used in these two circuits. Okay, galvanometer is not showing any deflection. That means no current is flowing through this one galvanometer. That means it's a which connection? It's obeying Wheatstone's bridge principle, right? So here if it is obeying Wheatstone's bridge, we can write it as 4 by R1 will be equal to 6 by 9, right? So R1 will be equal to 4 into 9 divided by 6. Clear? And here the same way while we are calculating this one, 6 by 12 will be equal to R2 by 8. Now we can find out the R2 value. R2 equals 6 into 8 divided by 12. So what is the ratio? R1 is to R2, R1 by R2. How we can find out? R1 by R2 equals R1 is 4 into 9 divided by 6 divided by R2. So taking the reciprocal and multiplying 6 into 8. So 2 here and this is 2 here and here it is 3 by 2. So we will get the ratio as R1 is to R2 equals 3 is to 2. Okay, clear? So next we will do the numerical based on the meter bridge. Okay, so yesterday we didn't do any numerical based on that, right? This is a previous year question. When two known resistances R and S are connected in the left and right gaps of a meter bridge, the balance point is found at a distance L1 from the zero of the meter bridge via an unknown resistance X is now connected in parallel to the resistance S, and balance point is found to be L2 from zero end of the meter bridge via. Obtain the formula for X in terms of L1, L2 and S. Okay, the same question is asked in 2009 as well as 2017. Okay, so both years it is asked. So we will try to do that. So this is the diagram. So the meter bridge apparatus is given, and first what is there? One R is in left gap and S is in the right gap. While we got a balancing length as L1. Okay, so how the formula as per meter bridge? What is the formula? R by S equal L divided by 100 minus L. So this is L1. So L1 divided by 100 minus L1. Okay, this is for the first case. Now S and X are connected in parallel. Okay, so instead of that S, now a parallel circuit is coming. So that effective resistance SP I am writing Sx divided by S plus X. Okay, now then we are getting a balancing length of L2. So balancing length equals, yesterday itself I told you to find out the series and parallel connection also we will be using this meter bridge. Okay, now the balancing length is L2. Then how we can write down this equation? R by SP will be equal to L2 divided by 100 minus L2. Okay, here what we should find out? Obtain a formula for X. We should find out a formula for X. Okay, now R by S is equal to L by L1 divided by 100 minus L1 and L2 divided by 100 minus L2. X we should find out in terms of L1, L2 and S. Okay, so R is not required. So from here, from equation A, this is A I am writing, this is B. Okay, from A I can write R equals S into L1 divided by 100 minus L1. From B, I can write R equals L2 into SP divided by 100 minus L2, right? So both are R. So I am equating the right hand sides. S L1 divided by 100 minus L1 is equal to L2 into SP divided by 100 minus L2. Right. So now we got the value of SP. Instead of SP, I can substitute it as Sx divided by S plus x. So S L1 divided by 100 minus L1 is equal to L2 into Sx divided by 100 minus L2 into S plus x. Clear? Now S and S will get cancelled. We need to find out x in terms of L1, L2 and S. So x is not required over there. So next I am writing it as S plus x divided by x. Okay, and equal to L2 divided by 100 minus L2. L2 divided by 100 minus L2. Here 100 minus L1 divided by L1. Okay, like that it will be. Now S by x plus 1, that is equal to L2 by L1 into 100 minus L1 divided by 100 minus L2. Right, then what is S by x? S by x equals L2 by L1 into 100 minus L1 divided by 100 minus L2 minus 1. Okay, so we can solve this and find out the final answer. So this one is L2 into 100 minus L1 minus L1 into 100 minus L2 divided by L1 into 100 minus L2. Okay, that is S by x. Now we can write down x as, so x is equal to S L1 100 minus L2 divided by L2 into 100 minus L1 minus L1 into 100 minus L2. Okay, clear? So this is how we will be solving this equation. Here if you want, you can write it as 100 into L2 and 100 L2 minus L1 L2 minus 100 L1 minus L1 L2. That one will get cancelled and you can write down the final answer as S into L1 into 100 minus L2 divided by 100 into L2 and minus 100 into L1. So 100 into L2 minus L1. Like that we can write down. Okay, so that is only solving the equation is little bit difficult, others everything easy. So it's an easy question. So if you know the Wheatstone's bridge, you can easily find out. Okay, so for the same way I'll give you one check your concept question also. Write down the question. The experimental setup of a meter bridge is given. The null point is found to be 60 centimeter. Okay, away from the end A with X and Y positions as shown in the diagram. Diagram also given. When a resistance of 15 ohm is connected in series with Y, the null point is found to shift by 10 centimeter towards the end of the wire. That is 10 centimeter reducing. Okay, then find the position of the null point if a resistance of 30 ohm were connected in parallel with the Y. Okay, so I'll draw the question. You can write down this question while I'm reading itself. You can write down the question and the diagram I'll give you now and you can solve it. Okay, so this one you can try. This is the diagram which is given in the question. It's a previous year sample paper question. Okay, so you can find out and tomorrow's video I'll be explaining about this. Okay, so next we are going to study about potentiometer. So what is this potentiometer? Potentiometer is an instrument used to find out the potential difference between the 2 points. Okay, when it is connected in a circuit. Potentiometer is an instrument used to measure using potentiometer, we can find out the potential difference between the 2 points in a circuit. Okay, so potentiometer is used to find out potential difference. Used to find the potential difference. Okay, what is this potentiometer? As I said in the previous case, here also potentiometer is a wooden board which contain a long wire. Okay, so in some cases it will be a single wire only. In some cases it will be having 500 meter length, or it is 600 meter length, or 1000 meter like the 10 meter. Okay, not 1000 meter, 10 meter length it will be. Okay, so like that it will be changing. Okay, so 10 wires it will be. It is 1 meter and 10 meter, like that it will be there. Okay, so one point I am connecting it as A and the other point is B. Okay, so usually here the down connection for the easiness, that also for the easiness we will say it as A or B. That depends, you can take it in any way. Okay, that is not an issue. So, and this here, in this, first we will be connecting it to a cell, a key, and then a rheostat. Rheostat is a variable resistor. Okay, so this is how it will be connected. And here, from here we will be connecting it a voltmeter, and it will be connected to a jockey. Okay, that is, this is positive, this is negative. This is the arrangement for potentiometer. This is also there in your practicals. Okay, it's important. This diagram, potentiometer, potential difference, how it will be using, how we can find out the potential difference of between the 2 points in the circuit. That one we are going to find out now. So before that, first we will find out what is the principle behind the potentiometer. Potential drop between the 2 points is directly proportional to the length of the wire. Potential drop is directly proportional to the length of the wire, in which the length of the wire is, which is having uniform area of cross section and uniform current. Okay, so wire is having uniform area of cross section and uniform current. Okay, current and area of cross section of the wire should be same. So V is proportional to length of the wire. That is the principle behind the potentiometer. Okay, potential drop across the 2 points is directly proportional to the length of the potentiometer wire. Okay, to which length with that and all we will tell. Okay, the whole length or a portion of the length, that and all I will tell you now. Is how we are getting this one. See, I told you for uniform area of cross section and uniform current, right? We know V equals IR. And R equals rho into L by A. This also we learned, right? So I am applying over there I rho L by A. I is uniform, constant, A is constant. We know for a particular material, rho also will be a constant. So we are getting it as V is equal to constant K into L. Okay, this is a constant, right? So I can write it as V is proportional to L. This K is called as this potential gradient. K is called as potential gradient, that K is equal to V by L. Okay, these portions and all you should learn properly, otherwise many questions can be asked at the time of Viva also. So V by L is called a potential gradient. K is equal to this constant K, that is I rho by A, that is K, that constant K, otherwise we can find it out as V by L, which is called as potential gradient. V is proportional to L. So if we are drawing a graph between potential and length, we will be getting a straight line. Okay, clear? Next we are going to find out how we can find out the potential difference. Okay, in a circuit, how we will be finding out using this potentiometer. Okay, so this is the how to find out the potential difference. Okay, how we are finding out the potential difference. This is the circuit diagram for this. So what change you are observing here? Here you can see this is the potentiometer which I am drawing. Okay, so this is a resistance box. Okay, in the previous diagram I showed it as a rheostat. Resistance box also a variable resistor only, but there we can identify how much resistance we included in the circuit. Okay, if we are taking out 1 ohm, so we know that resistance is 1 ohm resistance, we took it out. 1 ohm resistance is included in the circuit. Like that we will understand. But if we are using a rheostat, we won't be able to find out the resistance. How much resistance we included in the circuit. To know that clarification, to get the value correctly, we are using a resistance box over here. Clear? So here a key and a cell positive is connected over here, and we connected an external resistance which we are going to find out the potential difference. Okay, as an EMF. This one E1. So this is having EMF E. Okay, so it's connected like this. Clear? How we will be doing the experiment here? First, what we will be taking out a suitable resistance from the resistance box. First, we will take out suitable resistance from R. Suitable resistance from R. What is that suitable resistance? See, suitable resistance means, while we are keeping, after taking out a resistance, if we are keeping at the point A and at the point B, the galvanometer should show deflection on both the sides. Suppose if this is the galvanometer, so here I didn't connect the galvanometer, right? So this is a galvanometer. Okay, so if this is the galvanometer, if no current is there, it will be here in the center, at the center. Okay, so if I am keeping at the point A, the galvanometer needle will be deflecting to one end, and if I am connecting it to the B, then galvanometer deflection will be showing at the opposite end. Okay, so while taking out a suitable resistance means, while taking out as a resistance from there, at the point A, galvanometer will show deflection at one end, and at the point A, B, it will be showing in the opposite end. What is the meaning of that? In between these two, see, this is the two ends of the wire. In between, at one point, the galvanometer will show 0. Right, so then only, say, first at the point A here, and after covering like this only it can come to this side, right? So we are touching in both the sides and checking whether deflection is there at the both the sides. Okay, then next what we will do, so while doing this one, what is happening actually, we are making the potential drop which we need to find out should be greater than the potential drop here in the circuit, in the wire. Okay, while doing this, potential drop is fall of potential drop at the wire will be greater than the potential difference at the to be determined. Okay, to be determined. Okay, this is the reason we are taking out a suitable resistance and checking the both the sides deflection. Okay, potential drop at the end of the wire will be, should be greater than potential drop or potential difference between the which is to be determined. Okay, now that is the first step. Then what we will do, so this one we will be doing after closing this one. Okay, next this is K and this is K1. Next we will close K1. Second, close K1. This one while we are doing, first itself we should close. So circuit K is closed only first. First K is closed and doing this step. And then after that we are closing K1. While we are closing K1, what will happen? Current will flow through. Current will flow through R1. Right, current will be passing through this R1. So, and we will be finding out the balancing length. So, at a particular point where it is getting 0 deflection, that one we are finding out. Let it be L. L be the length where we are getting a null deflection. Null deflection means potential drop. Okay, balancing length is L. Balancing length means, what is the meaning of balancing length? Potential difference is equal to, potential difference to be determined will be equal to potential drop in the potentiometer wire. Okay, wire having length L. Okay, so the potential difference will be equal to potential drop across the length L. So first we need to find out the potential drop across the length L. So how we can find out that V equals potential drop across the length of the wire, V equals I into R. Okay, R, how we can find out? I into R. What is this R? Small r represents the resistance of the potentiometer wire. So what is this V? V is the potential drop in the wire. If we are finding out this wire, we can find out the potential difference between the end points of this C and D. Okay, so for that we are going to find out the potential drop across the point, across from A to J. Okay, that only we gave it as L. So V equals I into R. Now what is I here? Current, how we can find out? What is the EMF which is flowing? E divided by capital R plus small r. Here what is the total resistance? This is in series with the circuit, right? So here how much of resistance it is applied, plus what is the resistance of the wire? I is equal to E divided by R plus R. Now we need to find out the resistance. V is equal to E divided by capital R plus small r into R. This is the potential drop, total potential drop across the whole length. Okay, now what will be the potential drop across in unit length? If capital L is the total length of the potentiometer wire, then potential drop in unit length will be E by capital R plus small r into R divided by L per unit length. Okay, then what will be the V in potential drop in L length? Why we are calculating L length? Because L length only we got the potential drop, that is equal to potential difference, right? So L length will be E by capital R plus small r into R by capital L into small l. Okay, so this is the formula which is using to find out the potential difference between. So this potential drop across this much of length will be equal to the potential difference between C and D. So E by capital R plus small r into R by L into L. Okay, clear? So this is how we will be finding out the potential difference. So it is here, you should remember that how to find out what is the principle. V is proportional to L. V by L is a potential gradient, and this one, how to find out this potential drop or potential difference. Simple only. First this diagram. Okay, next close K. Find out the give with check between A and B, you are getting both the sides deflection. For that you should take out a suitable resistance from resistance box. Next, close K1. Find out the balancing length. So potential difference will be equal to the potential drop across this balancing length. Next we are going to find out what is the total potential. P is equal to IR. What is small r? Resistance in the wire. Okay, now V in unit length we are finding out, and finding out the V in L length. Clear? So you just write down and study once more and identify. See, and this thing while you are doing your practical, maybe you will be understanding more, you will be getting a clear-cut idea there, but this theory and all you should remember nicely. Okay, so I think it is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.